Welcome to Bold at CityU. I'd like to share with you today electrifying the future, every day and everywhere. Imagine that you can have the impaired people to see again. What about having artificial tumors that the doctors can use to help the patients to kill cancer? What seemed to be unbelievable before is now a reality, thanks to electrical engineering. What is electrical engineering, or EE in short? Why is it that it's with us every day and everywhere? Electrical engineering includes computer, internet, and cell phones. We also build all the microelectronics and control system. We have communication system that sits on satellite station and also rides on the spaceships. We develop a lot of sensors that allow us to collect tons of data, and we use artificial intelligence to analyze them. Furthermore, we also generate biomedical systems that can be used for diagnostics and treatment. Therefore, we can see that EE is with us everywhere and every day, just like the air around us that we breathe in. We cannot live without it. Why did I choose EE? Decades ago, when I was a freshman on campus, I was really excited to see that there's so many different majors that are very interesting that I can choose from. I had considered astronomy because this allows me to study the whole universe. I also like chemical engineering because I can create green energy that could help to save the world. What about electrical engineering? I believed that it is an exciting area. There are many inventions happening in the Silicon Valley that lots of young people are there to try to make the computers much better and faster. At the same time, the computers become smaller and much less expensive. I find that to be very amazing because most of anything else that we have, when they perform better, they often become a lot more expensive and much bigger, except microelectronics. Therefore, I believe that by being an electrical engineer, I can create something new that can help others. I also thought that choosing EE would be easier for me because I was good at math and science, which are the tools for EE. Years later, all these reasons that I chose EE are still valid. There's one exception for me. Indeed, studying EE was easy for me, but I did have to work very hard. All these students who told you that they can get A's without putting in any effort, that is simply not true. For anything that we want to be really good at, we do have to put in extensive amounts of time and effort. How does EE benefit the world? As electrical engineers, we are responsible to make all the EE applications to be better. It could be those faster computers, much quicker network, or the better communication channels that allows the kids to be able to talk to the parents or even the grandparents thousands of miles away. We are also coupling robots with control systems so that we can build more reliable autonomous cars. By developing new devices and being able to deliver power more efficiently, we can have a sustainable and cheaper energy system. Using artificial intelligence as well as the big data that we got from our sensors, that helps us to resolve the crime much faster and better. Nowadays, we can even develop better online teaching during these pandemics. Why is the job of the electrical engineer so exciting? As engineers, we have these huge responsibilities. We need to make decisions for the whole society. For example, we have to decide who should have the priority for those breakthroughs in biomedical devices that can help the cancer patients. We also need to have a balance between personal privacy versus safety in the society. Also, we have to allocate resources either to some of the areas related to the elderly so that they can have the point of care treatment, or create more opportunities for the young people to have new jobs in the high-tech area. We need to balance the technological risks and opportunities for future inventions and policies. We are here to create, to invent, and to discover. We need to make the impossible innovations and advancement to happen. As electrical engineers, we go from ideas to implementation, and we eventually go from the conceptual stage all the way to the final products. What is most important as engineers is that we need to work closely together as a team player. We need to work together with people from different backgrounds so that jointly together, we can go from the designs and finish it up with the new products. My own involvement in EE has gone through different stages. I started in the electrical engineering department at Princeton University, studying microelectronic devices for my PhD thesis, and then I worked on basic fundamental device physics all the way to integrated circuit technology. While I was a student there, I was very fortunate to have an internship at Bell Laboratories. I was able to work with the best engineers, and we are all working towards making the next generations of integrated circuits better. One of the outstanding engineers was Simon Z, who led the team to develop reliable oxides as well as clever designs for new transistors. In the team, we also had George Smith, who was Simon's boss. He was awarded the Nobel Prize in charge coupled device. At Bell Labs, we work on devices that has micron size. Later, after I graduated, I joined MIT Lincoln Laboratory. And we work on submicrometer devices, and we are changing the transport mechanisms of electrons from classical theory to quantum effect. With that, we are able to develop many exciting devices that has multiple new functions, as well as much better performance. We also focus on developing the technology that we can eliminate the defects in the devices so that the devices and the circuits will be more reliable. Later, I joined University of Michigan, as well as now being at City University of Hong Kong. I continue to develop nanotechnology for electronic and photonic devices. We also extend our activities beyond the devices and move into the biomedical microsystems. Why is EE the everyday and everywhere technology? Because electrical engineering involves evolution of technology. Take printing technology as an example. It was one of the 4 greatest inventions in ancient China more than 1,000 years ago. Printing allows the common people to be able to gain the knowledge from the printed books. the technology allows books to be produced at low cost in mass production. Therefore, it's very important that we got a huge group of people to be educated. This important technology got evolved to become the advanced nano imprint technology. This is a fascinating technology where very small features can be printed, and we can build devices all the way down to atomic size level. This nano imprint technology also has the advantage that it can be used with much higher uniformity at much lower cost compared to other available technology. What is especially unique for nano imprint is that we can build three-dimensional devices and microsystems that typically will be very difficult to be carried out using other available technology. With the nanotechnology that we developed, we have made different quantum effect devices, including these self-aligned field emitters, as well as the chemical sensors that allowed us to be able to detect a wide range of chemicals with very high sensitivity. CityU not only make those devices and chemical sensors, it can help people in the daily life and can even save lives. Look at some of those biomedical devices that we developed. They can benefit people who are suffering from different diseases. This is an example of the flexible neuroprobes. The neuroprobes can make the blind people to be able to see. What we did is that we developed some of the flexible membranes where we can dynamically control the membrane's curvature so that they can curve and match exactly our retina. On top of those flexible membranes, we have the electrodes. Through the electrodes, we can send the stimulating signals so that they can produce the visual signals to our brain. In this way, people who lost their eyesight will be able to see again. What else can we do with nanotechnology and engineering designs? What about an artificial tumor? Usually, electrical engineers, they will control the electrons or photons in devices such as transistors and lasers. Using similar approaches, we developed some of those three-dimensional platforms that allow us to control the movements of biomolecules and cells. We use the 3D nanotechnology to generate the artificial tumor that mimic what it would be in real life. At the same time, we added additional elements so that we can have topography, coating, designs, layouts, as well as electric fields, so that we can control the cell migration behavior. With the three-dimensional artificial tumors that we developed, we were successful in separating the cancer cells from the normal cells. With this, the device potentially can be used to remove the cancer cells from the patients. All these examples that I have shown you earlier indicated that what could not be imagined before now is a reality for helping others. Isn't it amazing what an electrical engineer can do? CityU has created many electrifying innovations. Just as exciting are the innovations that are yet to be defined. Thank you.